When I was asked by Teachers TV to teach a pair of maths masterclasses, I decided to tackle two topics that can be both tricky to teach and that students don't always see the wider point of. They're both topics that it's possible to have a lot of fun with, and I'm hoping that's what this group of Year 10 students from 3 North London schools will think too. What's the probability that your bus to school will be late tomorrow? What's the probability that David Beckham will walk into your life in the next 5 years? What's the probability that we'll have an earthquake tonight? What's the probability that I can juggle these 3 balls for 10 seconds without dropping them? Count. 1, 2, 3. 4, 5, been practicing. 6, come on. 7, Mum will be so proud. Oh. You know, life is a game of chance. And it's made up of a series of events that might either happen or they might not happen. What one thing is for sure is that we can use mathematics to help us make the right choices, to maximise our successes and to minimise failure. OK, now then, ooh, these look nice. I'd like a volunteer, please. A volunteer, look at my lovely doughnuts. Krishnan, up you come, put your clipboard down. Excellent. OK, choose one of my lovely, sugary, jammy doughnuts. Look good. Do they smell nice? Ooh, it makes you want to lick your lips, doesn't it? Lovely. Well, Christian's going to eat this without licking his lips. You think you can do it?
Definitely.
Without licking your lips once?
Yes.
We've got to keep watching him. Who thinks it's likely that he's going to lick his lips? OK, you think it's likely. OK, then. After 3, 1, 2, 3, go for it. Watch him carefully. No licking. Watch him carefully. Oh, that's sugar. Watch him carefully. Watch him carefully. Oh, what's your name?
Mickey.
Up you come, quick. Take a donut. OK. What I'd like you to do is face each other. Take your donut. Right, you eat your donut too, but you can lick your lips and look at him. Lick your lips. Go on. It's like eating him. Lick your lips. Put him off. Go on. Lick your lips as much as you can. That's it. Oh, look at that tasty. Oh, look at those lips getting licked. Has he been practicing? Try and put him off. I think he's done really well. Give him a round of applause. You can lick your lips now. That is absolutely fantastic. Take a marshmallow. No, take a handful. Go on. Is it nice? It's lovely. OK, well done. Marshmallows. Excellent. OK, fantastic. That is actually a fantastic performance. Now, is it true that one person's actions there, OK, well, 2 people, because I was involved as well, was putting him off? We were licking our lips and trying to put him off. We were trying to increase the probability, weren't we, that he would lick his lips. We were influencing the probability, and therefore his chances weren't independent anymore. We were trying to affect his probability. Now, in life, there are things where we don't have such an influence, where we do have events that are truly independent. Coin tossing. Put your clipboards down, come up and get a coin from me, a 50p coin. Up you come. I'd like you to choose a coin and find a space. We're going to do a bit of tossing. Choose one of my coins. Dahlia, excellent. We've all got a coin, everybody? Right, what we're going to do after 3 is toss our coin, flip it up in the air, catch it on our hand, try not to drop it, and have a look at what you get. OK, if you get a head, you've lost. I want you to take your coin and yourself and sit back down. If you get a tail, you can stay up, because tails never fails. OK, after 3. 1, 2, 3, toss! Catch! OK, what do we got? Heads, sit down. Tails, stay up. What have you got? Head, sit down, unlucky.
That's a tail.
Oh, yeah, it is. Of course it is. Tails. Tails, stay up. OK, tails, gather round. Gather round. How have we got now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. OK, we've got 8 people sat down. OK, toss 2 after 3. Same rules apply. The second toss. We're going to toss again. 1, 2, 3, toss. Tails never fails. If you get a head, sit down. Be honest, sit down. OK, that's 2 tosses. OK, let's everybody face the audience. Face the audience. Lovely. We have 5 contestants left. OK, toss 3. 1, 2, 3, toss. Flipping head. Get it? Flip. Yes. Tail. You've stayed in.
Tail.
Any heads? Sit down. Unlucky. 3 tosses. Good try. No, you can keep it. You can keep it. The 4th toss. The 4th toss. 1, 2, 3, toss.
Tail.
Tails never fails. How many have we tossed so far? 4. Got 4 tails in a row. Wow. We could have a winner here. Toss 5. 1, 2, 3, toss. Leave it, let's see.
I got a tail squad.
Tail again. 5 in a row. Do you think that's likely? No. Right, let's try for 6 in a row. Okay, 1, 2, 3, toss. Toss 6.
Tail.
Tails. Tails. Wow. Are you sure these coins are fair? Right, toss 7. 1, 2, 3, toss. Good flip now. Head, unlucky. Tails, we have a winner! Congratulations. I tell you what, that was pretty terrific, okay? 7 tosses in a row. Does anyone know what the probability of getting 7 tails in a row is? How are we going to work it out? Okay, we're having a think. What do you think, Arnold?
You do half times half.
You do a half times a half? A half times a half, isn't that a quarter?
No, to 7 times.
Right, why do you do a half times a half 7 times?
To get the probability of it.
Okay, right, you've got exactly the right idea. The first toss, let's break this down. The first toss is a half chance of getting a tail or a head, isn't it? So we write down the probability of getting a tail, 1 tail in a row. 1 tail in a row is, well, there's 2 equal likely outcomes, heads or tails. This looks like a tree diagram. Okay, the second toss, of course, gives us 4 equally likely outcomes. There's only 1 outcome that we want. Tail. Okay, don't be a telltale. Right, the next toss, that's the third toss, gives us how many equally likely outcomes? Shout it out. 8 equally likely outcomes, and so on. So a half times a half times a half, and keep timesing by a half. Each time we're going to double our outcomes. 7 in a row is a half to the power 7. Who's worked that out? Half to the power 7. 1 over... Who said that? Edward. 1 over 128. That is quite amazing. You lucky person. 1 over 128. Where are you again, the lucky person? Where are you? Adam, it was amazing. Are you still stunned?
Yeah.
Come up here. You still got your coin? Put it in your pocket. Give it a magic rub. Okay, let's try 8 in a row. Go on.
Okay.
Go for it. A really good flip. Head. Unlucky. I thought you were on a winning streak as well. Right then, on the 8th toss, what was the chance of him getting a tail on that 1 toss?
1 in 200, yeah.
No, on that 1 toss. A half, okay? Because we've had an independent event, followed by an independent event, followed by another independent event, and so on. Past history does not influence it. Okay, 7 in a row is a half to the power of 7. Okay, what's the probability of getting n tails in a row? I'll start you off. A half. Mumina?
Half to the power of n.
Half to the power of n. Excellent. So 8 tails in a row. When n equals 8, what's the probability? Shout it out. 1 over.
8.
Okay, let's calculate it, okay?
2n.
A half to the power of 8 is 1 over
256.
256. Good. A half to the power 8. Okay, I'll do the 1 over bit. A half to the power 9. 1 over... Quick, mental skills. 512. Good. A half to the power 10. 1 over... 1024. I wonder what the probability is that I'll get all those coins back off you, eh? Right then, let's move on to another interesting, very familiar situation. Here's a dice. 1, 2, 3, 4, 5, 6. How many equally likely outcomes on that dice, Meg? Okay. What's the probability that you throw a 1?
1 6.
Throw it. Are you feeling lucky?
Not really.
Woo! Oh my goodness! It's a 1. Well done, Meg. It was 1/6 chance, you lucky person. Okay. Right then, that's interesting. What's the probability that, just hold it there for a minute, if Meg throws it twice in a row, she gets 2 ones. From the beginning again. 136. Good. So the probability she gets a 1 on her next go, of course, is 1/6. But she's already got the 1. So let's do another one. Would it be a 1/36 chance? It's not going to happen again, is it? Oh, unlucky. But the probability of getting a 1 followed by a 1 is 1/36. That is because, of course, we have 1/6 times 1/6, which is 1/36. 36 different ways that dice can land, okay, when I throw it twice. Let's take 2 dice. What's the probability that I get a double 1 on 1 throw? Why? Mikhail?
Because they're independent, so it doesn't matter if you do after each other.
Exactly, or together, simultaneously. 1/36, fantastic. What's the probability of getting a double 6?
1/36.
Okay, more interesting question then, because you're a bit clever, yeah? What's the probability of getting a total score of 7?
That's quite a lot, because
Quite.
the different numbers make up 7.
What make up 7 then? Come on, do you want to write them up?
2 and 5.
Krishnan, do it. And write them on the board, yeah? Give you a fresh piece. The different numbers that make up 7. I love that. Krishnan got that just right. 1 and 6. That's one way. 2 and 5. Is he right? 3 plus 4. Is that it?
Yeah.
So there's 3 ways, yep. So the probability, yep, that's brilliant. 3 out of 36. Everyone happy?
Yeah.
Good, because I'm not. Oh, Anton, why aren't you happy?
Because it's not simplified.
Well, that's good, actually. Yeah, it would simplify to a 12th, but that's not the reason. OK, let's look at it. A 1,
You can do it the other way around.
a 1 and a 6, yeah. OK, you could get a 1 on that dice, a 6 on that, but you could also get, and this is another outcome, a 6 on that and a 1 on that. OK, 2 different ways that give you the total of 7 using 6 and 1. So actually, the probability is, yes, OK, which is in fact 1/6. What's more likely, getting a total score of 7 with 2 dice, or throwing a 4 with 1?
Same.
Equal, 1/6. Excellent, OK? And very interestingly, 7 is the most popular total. It's the most likely out of all the totals, and yet, key question, if I throw these 2 dice, am I likely to get a 7, even though it's the most likely? Am I actually likely to get it?
Depends what you classify likely as.
OK, all right, well, likely is more than half chance. That's exactly what likely is. It's more than a half chance. Is it more than a half chance that I'm going to get a total of 7?
No.
It's not. So it's not going to happen. Never mind. Oh, it would have been nice if it did, yeah? But we can still say that 7 is the most likely score. Interesting. Do you know what the probability is, Edward, of winning the jackpot on the National Lottery with 1 line of numbers, 1 line of 6 numbers?
It's like 1/1,billion.
1/1,billion. That's interesting. A billion to 1. Yeah. Anyone else? You think it's? Does it what? Sorry. Right. Well, that's a very good, interesting response there. Does it depend on how many people are playing? Your payout depends on the number of winners, doesn't it? But forget the winners for the moment. Good point, and we'll come back to that. What's the probability that with 1 line of numbers, you get the 6 numbers and you are a winner? OK, well, we'll look at working that out and we'll have a little think about it. We must remember your question too. What we're going to do is have 1, 2, 3, you 4, please, up here. Thank you very much. OK, could the rest of you come all up to the front and get yourselves into a circle with your backs inwards. 6 hands, 6 balls. Fantastic. OK, what we've got is the National Lottery here. All right, now then, we've got 49 balls inside that machine. 6 of them are red and 43 are black. 6 of them are winners, 43 aren't winners. I want all 6 reds to come out, all of them, in a row, and then I've won the lottery. And I've got my picker in here, who is blindfolded. He can't see a thing now. I don't want you to help him. I just want him to scrabble about in the balls. In a moment or two, he'll be scrabbling about in the balls and throwing balls out at random. I wonder if he's going to get 6 in a row. Hey, good luck! They'll need it. let's start! Good try. I can see it. It's out. That's good. Oh. Ball 3's coming out. Yeah, chuck it. Good. Ball 4. Quick, 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 machine. Yeah, we're doing really well. Go, we're doing really well. Come on. 6 reds. 5. Brilliant. Oh. Brilliant. We've done it. Do you want to know how many you got, Mikhail? None. Never mind. Take your blindfold off, Mikhail. We've got 6 blacks. We don't know what numbers they are. We do know that they are 6 of the balls that we didn't want. So we've lost. We haven't got even one number. All right? We wanted 6 in a row. Is it going to happen? Yes. Is it going to happen? It could do. What's the probability that we're going to get red, 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 and red? Difficult, isn't it? It's the probability of winning the National Lottery. Let's have a look. Chuck those balls back at him. Go on. Chuck him in. Right then. Ball collectors back on your stage. OK, this time, what I'd like to do is stay in your circle, and without releasing the balls, can you all turn around 180 degrees and actually face Mikhail? Let's go through a simulation, but this time we're going to do the winning simulation. Goodness me, what's the chance? OK, randomly, that the first ball coming out is actually red. 1/49. But there's 6 of them, isn't there? There's 6. 6 out of 49. Are you sure? The chance of getting the first ball is 6 out of 49. Good. OK. Right, second ball. What's the chance?
5 out of 48.
5 out of 49. 8. Why? OK, the number of reds is reduced, the total number of balls has been reduced, and so on. Third one. Tell you what, chuck it at them instead. There you go, Meg. Next probability, hang on a minute. Ball 3, shout at me.
4 out of 47.
OK, just a minute, just a minute. 4 out of 47. I'm getting old, yeah, I can't keep up with you. Fourth ball is
3 out of
46. Excellent. There's only 2 left in there. Chuck it. 2 out of
45.
Last one, the last one to come out. There's only 1 red left, and how many are left in here?
44.
4. Excellent. Well done. 6 out of 6. Round of applause. Imagine if that had happened, eh? Well, here we have it. We have the probability here of winning the National Lottery. It's easy, OK? We multiply the numerators together, and we multiply the denominators together. So it's easy. 6 times 5 times 4 times 3 times 2 times 1, divided by 49 times 48 times 47 times 46 times 45 times 44. Simplify that down. We do actually get a fraction. 1/13,983,816. Wow! 14 million to 1. That's amazing, isn't it, eh?
Yeah.
Would you believe it? Do you think you'll ever win it?
Maybe.
Maybe. If you keep playing every week, you might win it. In fact, Yasmin, if you played it every week, do you know what? You would eventually win.
Really?
After about 269,000 years. So good luck. All the best. 269,000 years. I'll see you then, and we can share your jackpot. Brilliant. Of course, you won't be winning it because you're not old enough to play yet. So, very interesting. So whichever line we put on, so that's 6 numbers chosen at random, whether it's a lucky dip or whether it's the numbers, I don't know, Mickey, 1, 2, 3, 4, 5, 6, OK, has a probability of 14 million to 1. 14 million to 1 chance that we're going to win the jackpot. So, shall we, Mickey, shall we put the numbers 1, 2, 3, 4, 5, 6? Or shall we put on, ooh, Alex, shall we put on a lucky dip? What do you think's better? What's got the best chance? Lucky dip or 1, 2, 3, 4, 5, 6?
1, 2, 3, 4, 5, 6.
Pardon?
1, 2, 3, 4, 5, 6.
You think it's more likely you're going to win with 1, 2, 3, 4, 5, 6? Who agrees with her? Oh, what do you think, Delia?
Lucky dip.
You think the lucky dip? Why?
It's just like numbers at random.
It's numbers at random. But 1, 2, 3, 4, 5, 6 is any 6 numbers too. All right, they're in a bit of a pattern, but they're random numbers.
I think they've got the same probability.
You think they've got the same probability. What's that then?
Just 1 out of 13,983,816.
OK. The probability that you win on any line of 6 numbers, whether it's nice consecutive numbers, whether it's a lucky dip, OK, whether it's my age, 29, 30, 31, 32, 33, 34, who knows? OK? But we do know that the probability of winning the National Lottery is 14 million to 1. However, coming back to your point, does it matter then? Is it better to do 1, 2, 3, 4, 5, 6 or a lucky dip? Well, what do you think? What did you say earlier?
I said, would it not rely on other people's choice of numbers?
Totally
as well?
rely. So if you were lucky enough to win the lottery, imagine it, £5 million jackpot, okay? And Alex, yep, you've put on a lucky dip and you're the only winner. You've just won £5 million. Round of applause. Okay. And the week after, would you believe it? 14 million to 1 chance. Do you know what numbers came up the week after? 1, 2, 3, 4, 5, 6. You've just won the jackpot too. £5 million. Well done. And she can share it with 10,000 other winners, because 10,000 people every week put on the numbers 1, 2, 3, 4, 5, 6. So once it's all shared out, she's a lottery jackpot winner, and you've just won 500 quid. Okay, book yourself for a week in Southampton. That'd be nice, yeah? Watch the seagulls. Lovely. Now, let's play a game where you can win a car.
Welcome to Probability, your chance to beat the odds. Now, here's your host, Johnny Healy.
Can we have our first contestant? Come on down, Lumina! Give him a round of applause. Oh, here we go. Now then, we're going to play a guessing game. Here's your guesser. Guess with my gold flower. What we've got 3 boxes. Inside one of the boxes is a car. Inside the other 2 boxes, we've got Brussels sprouts. Oh, go for it. Place your flower on the box you think the car's in. Okay, take your time. Okay. Are you happy with that choice?
Yeah.
Okay. I can tell you that if you'd chosen this box, you would have won sprouts. Woo. Yeah. What do you want to do? Do you want to stick with your first guess, or would you like to swap? We've narrowed it down to 2. What would you like to do?
Stick.
You want to stick. Why do you want to stick? Does it matter?
Guess.
Is it... Go on.
Random guess.
Random guess. You want to stick. You fancy sticking. OK, what would you do, Addo?
Stick.
You'd stick. Yeah, I thought you might, actually. What would you like to do, Alex?
I'd swap.
Would you swap? Why?
I know. I like the other one.
You like the other box? Anyone else who'd like to swap? OK, why?
Because you have a higher chance of winning a car if you swap.
You have a higher chance of winning the car if you swap. But there's only 2 boxes, so surely it's either in this box or it's in that box. Put your hands up. Let's have a little vote. Who would like to stick? Go on, put your hand up if you really want to stick. 11 stickers. OK, hands up for swap. That should be the other 8 of you. 1, 2, 3, 4, 5, 6, 7, 8 swappers. Interesting, more people want to stick. Right, you said you wanted to stick. The audience want to agree with you, don't they?
Yeah.
So you're going to stick?
Yeah.
OK, he's chosen to stick. Is that your final answer? Yeah. Your final answer. Do you think he's doing the right thing? Yeah! Is he going to win? Yeah! OK, we can now reveal that the middle box that you chose to stick with is... Sprouts! Oh! Let's have a look at what you could have won. The car. Have a look at that. Touch it. Just for a moment or 2, you haven't won it. OK. Unlucky. He could have won the car if only he'd swapped. Now we can start using maths, because your man's on the right tracks. There are 2 boxes there, but what you're saying really is that you don't think it's 50-50, do you?
No.
OK, even though there's just 2 boxes?
Yeah.
You're saying that these aren't equally likely, aren't you?
Yeah.
OK. Now then, put your hand up if you said stick. Stick. All 11 of you thought that is the best option. And I can't blame you. There's 2 boxes left, OK? 2 boxes. Now, Could be in either of these boxes. So you're thinking, well, it might be in that one, or that one, 50-50, half, I'll stick with it. Brilliant. What about the swappers? Well, whether you guessed or not, swapping is the best strategy. Let's prove it. When he chooses the middle box, what's the probability that he's right on his first guess? 1 out of 3. Remember that. It's always going to be 1 out of 3, yeah? I can't control which box he's going to choose. He could pick it 1 out of 3. What I can control is the other 2 boxes. OK. I know that I can get rid of one of these boxes. The probability that it's in this middle box is 1/3. The probability that it's in one of these 2 is what? In one of these 2 is 2/3. But I've effectively got rid of that and told you the answer that it's not in that. So it must be in that. The probability that it's in one of these 2 is 2/3, but it's not in that. What's the probability it's in this one? 2/3. Still 2/3. It was either in this one or that one. I've told you it's not in this, so I've given you extra information without you realising it, OK? And now I've influenced the probability. It's counterintuitive, but believe it or not, some of you are still thinking, well, I think it's half. I think it's half. Who thinks it's half still? Be honest, some of you are not convinced. When I first saw this problem, nor was I. And in fact, it's a very famous problem. Eminent mathematicians, when this was first circulated, were actually writing papers saying it was all a load of rubbish, that this is all a fix. But if we played it 300 times, we'd win 200 times. By swapping every time, we'd only lose 100. We can make the odds work for us. So, that's the probability experiment. Unlucky this time, Mumina, but well done. Give the man a round of applause. Well done. Yeah, take some sprouts. Go for it. So, that's what it's all about. Life is a game of chance. Life is a game of probability, but we've got to make the right choices. Let the maths work out the probabilities for us so that we can make the best chances. Maximise success. I'm Johnny Healy. Thank you very much.